Today we are going to talk about liquefaction of gases. Why do liquefy gases? There are three reasons. One is storage. For storage, for example, suppose you have 1 liter of a gas, okay? Suppose it occupies 100, suppose a gas occupies 100 liters. It seems same in the liquid phase, it becomes only 1 liter. That means there's a drastic reduction in size, volume, therefore storage volume. Especially are going to aircraft, they are taking, when the spacecraft, they want to take fuel like liquid hydrogen, etc. Liquid hydrogen and all. They liquefy. Secondly, for separation of gases. For example, you want to, air has got oxygen and nitrogen. You want to separate the, how do you separate it? Liquefy the gas, then remove oxygen and nitrogen. So for separation. And thirdly, for cryogenics. Cryogenics means very, very low temperature. The two things, refrigeration refers to 0 degrees centigrade. Refrigeration. Cryogenics is very low temperature. For example, air, the normal boiling point is minus 190. Normal boiling point means what? Boiling point at atmospheric pressure. So air normal boiling point is minus 192. Nitrogen is 195.8. Oxygen minus 183. Hydrogen minus 252. And helium 268.9. So for this cryogenics, they are used. Cryogenics is used in surgery. For example, suppose you want to remove some kind of a cancer or tumor in the brain, we use a cryogenic needle. The needle will be cooled to this temperature, and when you touch the needle on the tumor, it will become powder. Okay, so you can use cryogenics. Cryogenics is a very extended field, and liquid helium is used in many places. Okay, liquid helium. So this is the purpose of this. So you should know the difference between cryogenics and refrigeration. Now, so to get such low temperatures, we need some throttle valves. See, even if you have seen your refrigerator, there will be a small coil in the back side, there will be a big coil. This is a kind of a throttle valve. Okay? So, throttle valve is used for cooling. So, look at this. I'll give an experiment, Joule-Thomson experiment. Joule-Thomson experiment. Got a pipe like this, a throttle valve, and an outlet pipe, which is much bigger. Okay, here there is a pressure gauge, P1 and T1, and at the exit you have got a pressure and temperature gauge. It reaches P and T. So this is the inlet pressure and temperature, this is outlet pressure and temperature. This is a throttle valve. So when set a gas, this is a bigger pipe, there will be expansion. Okay. Now what you do is we are going to an experiment where we are going to keep the upstream pressure and temperature constant and change it downstream pressure. When you change downstream pressure, downstream temperature will automatically change. Suppose you plot a graph of temperature versus pressure. Temperature versus pressure. Okay. You will get a graph like this. For a particular upstream temperature and pressure, you change the downstream pressure and note down the temperature, you will get a graph like this. So here it will have dt by dp is positive, here dt by dt is 0, and here dt by dp is negative. Therefore, dt by dp is, now throttling, as you should know, is a constant enthalpy process, isenthalpic process. Throttling is a isenthalpic process. Isenthalpic. Throttling is a isenthalpic process. That means what? Constant enthalpy. So mathematically I can say dt by dp at constant h. That is a change of temperature with pressure as constant enthalpy is called Joule-Thomson coefficient. Mu is called Joule-Thomson coefficient, nothing but change of temperature with pressure at constant enthalpy. Now you see here temperature is a positive slope, here 0 slope, and here negative slope. This point at which there is 0 slope is called immersion point. Immersion point. So when dt by negative, so we got regions, three regions. dt by dp is negative. Negative. Here it is negative slope. here positive slope, here negative slope, here positive slope and zero slope. Positive slope, negative slope and zero slope. Now here you see in this region, as you decrease the pressure, temperature decreases. Okay, when mu is positive, okay, there is due to which is called, this slope is called immersion point, immersion curve. Now this at this point, this region dt by dp is positive. Therefore, as decrease pressure, temperature decrease. That means what is decreasing pressure? Expansion. Expansion produces cooling. Okay, expansion produces cooling. At the point inversion point. This is called inversion point. Inversion point, not immersion point. Inversion point. Inversion point. Where slope is 0. Okay, at the inversion point, dt by dp is equal to 0. That means as you change pressure, there is no change in temperature because T is constant. And here is negative. So dt by dp is negative. That means as you decrease the pressure, what happens? Temperature increases. So as you decrease pressure, temperature will increase. That means in this region, expansion produces cooling. In this region, expansion produces increase in temperature. And at this point, there is no change in temperature. This is called immersion curve. Now, like this is for one upstream pressure and temperature. So what I have done here, kept upstream pressure and temperature constant and kept on finding out the downstream pressure and temperature. Change the downstream pressure, find out the temperature. Change the downstream pressure and temperature. So I plot a window. Like that, I am going to plot for different upstream conditions. T versus P for different upstream conditions like this. And this here inversion point. I am going to join all the inversion points like this. Okay, this is what is the inversion point? Inversion curve. This is called the inversion curve. Inversion curve. What does the inversion curve do? You join all the inversion points, you will get the inversion curve. So within the inversion curve, slope is positive. Outside the inversion curve, slope is negative. And on the inversion curve, slope is 0. So we've got three regions. Slope inside the inversion curve, positive. Outside the inversion curve, negative. On the inversion curve, it is 0. That means if your pressure and temperature inside the inversion curve, expansion produces cooling. If your thing is outside the inversion curve, expansion produces heating. And on the inversion curve, expansion produces no change in temperature. So they have got three regions. Therefore, you want to cool a gas, you should be in this region. If you want to heat a gas, be here. So if you are inside the inversion curve, expansion produces cooling. Outside the inversion curve, expansion produces heating. Okay, this is the basics of liquefaction. So you are going to use this process for liquefaction. We will continue this later.